Hi, everyone. Thanks for joining today. I'm Justin Reock, the Chief Evangelist and Field CTO at Gradle. You may have heard some of my other talks before around open source and developer productivity. In general, my background is predominantly in software development, moving into enterprise architecture, but now I really focus more on evangelizing developer productivity engineering, which I'm going to talk to you about today. So let's kind of jump right into it. I like to start this talk with the following quote from Eric Pearson, who was the CIO at Intercontinental Hotels Group. And he says, "It's no longer the big beating the small, but the fast beating the slow." Okay. And I think that this quote adequately sums up the state of the art and the state of the industry right now. Okay. It's no longer the big giant software companies that are just dominating, right? It's the disruptive, nimble companies that are able to respond to customer and market feedback quickly and bring their features to market fast, right? And that's obviously what we're here talking about today with DevOps, right? That's the whole purpose, is to get around various constraints and to unstick bottlenecks and to convert our code into throughput faster. So we're going to talk today about a very specific problem around feedback cycles for developers and how that impacts developer productivity, because the practice of developer productivity engineering is very practical and very pragmatic and very straightforward. It's about identifying bottlenecks and friction in the software development process and then using technology to mitigate those bottlenecks. Okay, so here's your average developer doing their thing. They're in their local environment, but this could also apply to remote environments or even building out in CI environments. And they're waiting on feedback, right? They've written some code, they're going to run a build, and they want the build system to tell them something. Well, sometimes the feedback just takes too long, right? Sometimes the build takes minutes, in extreme cases, even hours, right? Or sometimes the test cycle takes too long. Maybe there's thousands of tests that have to be run, right? Maybe the feedback is okay, but it's a failure, right? There's some type of failure that has to be investigated, right? And maybe it takes too long to fix that failure or to try to collaborate on the fix with that failure with other engineers. And maybe, like, the worst case, it's a pitfall or a problem or a bottleneck that could have been avoided altogether, right? Maybe a flaky test, a test with like a non-deterministic outcome, or a failure that is actually impacting lots of developers in the organization, but nobody's talking about it because nobody's tracking it, right? So think about these pain points, these friction, these bits of friction and these bottlenecks, then multiply that by hundreds of calendar days per year, and then hundreds of developers times that. We end up sinking productivity and increasing cost, which is antithetical to constraints-based work and productivity theory. So backing it up just a second, okay, software development is still a creative process, all right? Even as practitioners, even as folks who do this for a living, right? This is still creative work. Now, it's not purely creative work. It's also scientific work. I think it's fair to say that it's a bit of both, right? We experiment with our code. We form a hypothesis in our mind. We run the code, and then we get the results, right? And we want to understand whether the work we did accomplished the task that we wanted to accomplish. And I think for a lot of us, when we started in this industry and we started down this path of like learning how to code, the experience felt like this very often for us, right? These were learning moments, right? We were achieving, we were running a hello world program for the first time in a new language, and we would run it and we would get the output, and that feedback would happen so quickly, right? Because they were very simple programs, right? Maybe we're doing a standard hello world, or maybe we're just changing the background color on a shape or something like that. But the point is that we would get feedback fast, and that fast feedback is part of what led to the delight of the experience. But as a lot of us have moved into more professional roles with developing software, especially in the enterprise, the success of software projects, ironically, creates a new set of challenges for us, right? As the projects become more successful in an enterprise, as more users start to use the project, as the project grows in size and the number of developers working on it, or the number of repositories that are necessary to support the development, just the number of dependencies that are being used, and just the overall diversity of the tech stack. Again, as enterprise projects get larger and larger, the tool chain efficiency starts to degrade if we're not managing it, right? So the build time gets longer and longer and longer. The test cycles get longer and longer and longer. And ultimately, the delight of the process and the happiness involved in the craft begins to diminish and begins getting replaced with some frustrations, right? So I think now, if you look at the day of the life of an average enterprise developer, their calendar might look a little bit like this for organizations that haven't fully invested in productivity engineering as a practice, right? The developers might come in, they're ready to go, and they start coding. Great. And then we're going to wait for our local build to complete. We made a bunch of changes and something failed in the local build. So we're going to spend some time debugging that build failure. Maybe we fix it and then go to lunch. Great. We're going to come back and we're going to code for a little while longer. We're going to wait for our local build to complete. Now we debugged the build failure that we had last time. So this time it's successful, but now we push that build to CI and there's a flaky test, right? There's a test that passed in our local environment. It did not pass in the CI environment. Now we're spending time investigating that. All right. So how much of this was spent doing what developers love to do, right? Coding. Not a lot, right? A lot of this is actually just spent with various frustrations, supporting the build, troubleshooting the build, debugging the build. So an outcome of developer productivity engineering then is to give developers literally hours back in their week to be able to work on